Hi everyone, this is coming to you from Education for All. This is video number 2 on this topic, sequence and series. First, we are going to study sequences, and then later we look at series. They go together, but they are different. They go together. You do sequence, you go to do series as well. But here we are going to talk about sequences. In the first video, we already explained what a sequence is and what type of sequences we are interested in studying. There are a lot of them. I named 3 here. Arithmetic sequence, some books call it arithmetic progression, geometric sequence, other books say geometric progression, and Fibonacci sequence. Don't worry about this, we are not going to look at it, just to let you know there are more sequences. Arithmetic sequence will say that every 2 consecutive numbers, the difference between them is constant throughout the sequence. So if that is the case, then that list of numbers is being described as an arithmetic sequence. So let's look at this. 3. Let's start with 1. 1, 4, 7, 11. Is this a sequence? Yes, of course. According to our definition, this is a list of numbers. It follows a pattern. What is the pattern? That consecutive numbers, the difference between them is always constant. Right? Between 1 and 4, the difference is 3. Between 4 and 7, the difference is 3. 7 and 11, the difference between them is 3. So every consecutive numbers, the difference between them is constant throughout this list of numbers. Therefore, this list of numbers is a sequence. So now, if you are asked to find the next term after 11, what will be the next term? How do you work it out? These are the things we are going to investigate. These are small numbers, but when the numbers are large, for this one here, you know what the next term will be. You can just count with your fingers. But when we are dealing with large numbers, then it becomes difficult to work it out mentally. So there should be a method of working that out. So for this type of sequence, we have here on the board, if they ask you to calculate the next number, you already know the difference between them is 3. So let's say it's 3n. It's 3n. So if we have 3n, and we know that's the difference between them is 3. This 3n is the unknown term. The unknown term. So but because the difference between them is 3, so straight away put the 3 times the unknown term. So now from here, how do you work out what the first term is? You know the first term is 1. The first term is 1. So if this is 1, this is the first term. If n is 1, yeah, you put now 3 times 1. You know it's 3. What will make me get 1? I want the first term. First term. You know, sometimes we have to understand formulas, not just memorizing the formula and use it. You can forget in an examination situation. You can easily forget things. You know, time is against you, anxiety, all these things will affect you. So sometimes it's good to understand how the formula is derived, so that if you cannot be able to state it mentally, you can be able to derive it. So that's what we are trying to do here. Now you know the difference between these numbers is plus 3, plus 3, plus 3. So therefore, to get the next one that follows, it has to be plus 3. Because you don't know what the next ones are, so you say times n, or you say times x or p, q, whatever letter is convenient for you, you state that. So now, having this one here, how do I get this first term if I want to determine what the first term is? And know the first term is 1. So what should I do to this equation? What should I add here to give me 1 as the first term? What should I add here? Provided now, because I'm looking for the first term, so now this n here will now be 3 times 1, which is 3 plus what will give me 1. So to get 1 here, I don't need plus, I need minus, because it is already big. So I need to subtract 3 minus 2, because 3 minus 2 will give me 1. So this now becomes minus 2. So your nth term for this sequence, for this one, these numbers here, to find whatever number will be, the next term is going to be 3n minus 2. So we call this the nth term. 1, 2, 3, 4. So if they ask us to find the fifth term, this is 1, 2, 3, 4. Now we want the fifth term. So this is going to be 3 times 5 minus 2. And 3 times 5, which is 15, minus 2, this is 13. So the next term will be 13. And you can see between 11 and 13, the difference is 4. It's 3, sorry. And what will be after 1, 2, 3, 4, 5? What will be the sixth term? Again, to find the sixth term is 3 times 6 minus 2. 3 times 6 is 18, minus 2 is 16. So the next term will be 16. So you can see it's all difference of 3. Plus 3, plus 3. So this is how we find. So for this sequence, the nth term, for this sequence, this particular one, the nth term is 3n minus 2. What's the time? 8 minutes. So now, suppose we are not given these numbers. Now we want to generalize. This nth term is specific for this list of numbers. Suppose we are given numbers like a plus n, a plus 2n, let me say d, so that we don't confuse the nth term. A plus d, a plus 2d, a plus 3d, plus. Suppose we are given a sequence like this. What this means, assume that d is 2 and a is 1. So which means here we are going to get 1. This is 3. We are assuming that a plus 2, a is 1, d is 2. So 3, a is 1, 1 plus 4 is 5, 1 plus, this is 7. So that's, we are just assuming. So you get a sequence like this. If we now assume that a is 2 and d is 1, a is 2 and d is 3, so you have here 2, a is 2, d is 3, here is 5. So you get something like this. So this is, you want to find a general solution or a general formula. So that's why we use these letters here. Because these numbers, these letters can change. They can take any number. Because for this function here, sorry, for this list of numbers here, its length term is this. From this formula, you can find the rest of the numbers up to 100, 1,000, a million. But suppose now we have this sequence. How do we find the nth term here? For this one, the nth term is equals to the first term plus the nth term minus 1 times the difference. For this one, first we are starting with the first term. If everything here is 0 or d is 0, the difference is 0, so you just get your a term. So for the next term, provided you know what this is, because the difference is always constant. You can see here a difference of 1d plus 1d plus 1d, because you see this keeps on increasing. 1, 2, 3. So this is the formula, and this is the general formula for the nth term of any arithmetic progression. Any arithmetic progression, this is the nth term. This can help you work out what the other terms are. Thank you for watching. Bye-bye.